In the previous videos, we've learned how to classify data with known class value using various techniques. All the techniques that we've seen until now are supervised techniques where we are trying to predict a class label for new data. Today, we will introduce the unsupervised learning techniques and later show how to apply to numerical data. Unsupervised learning techniques do not require a class label in the dataset. This kind of approach will try to find similarities and patterns in the data. The final cluster assignment needs to be interpreted and further described. All that we need is a set of data and a similarity measure. The algorithm will try to group together data points that are close to each other and they are distant from all the others in other clusters. One example of a clustering algorithm is the KMeans algorithm. This algorithm should be used only on numerical data, as the statistical inner working does not make sense for categorical data. The algorithm starts with some random centroids, data points that should represent an average, mean, of all the other points around them. How many? K, a certain number chosen by us. After deciding an assignment, the algorithm repositions the centroids and verifies the assignments. This iterative process usually ends when there is no reassignments of the data from one cluster to the other, or after a certain number of iterations. The silhouette score is used to decide which is the best number of cluster K for our data. It represents how good a single data instance is fitting the actual cluster. A positive value means the data fits the current cluster. A negative value means that the current data point is probably assigned to the wrong cluster. This can be plotted in a visual way, where we may look for clusters containing a majority of the bars on the positive side. Now, let's see how to perform K-means clustering using Orange. For today's task, we need a dataset that contains mostly numerical data. We will use a dataset containing the statistic of Premier League football players. Let's open it in Orange. From the data panel, add a CSV file import widget to the canvas. Double-click on it, click the folder icon. Select Import any file if you use the Windows version of Orange. Browse to the folder where you saved the Premier League XLS dataset. Select it and click Open. You can keep the import parameters at their standard values. You will see that in the info panel it reports that there are 571 rows, 58 features and 1 meta. Let's check what's in the dataset. Add a data table, connect it to the CSV widget and double-click on it. You can see the first feature is colored in gold. This is our meta feature, containing the player name. Other categorical features contain the jersey number, club, position and nationality. After this point, we have a long series of numerical features that report the performance of the British Major Football League players. We can find the number of appearances, wins, losses, goals, and many others. Some of them have missing values, represented by the question marks. With K-means clustering, we don't have to worry too much about the missing values, as the algorithm can handle them well. Now, let's apply the K-means algorithm and see what it can find out from our data. Let's add a Select Columns widget to the canvas from the Transform panel. Connect it to the CSV file import widget and then double-click on it. We will remove from the features list the categorical variable club, position, nationality and jersey number. Let's add the name to the metas. And we will use all the rest of the numerical features for our algorithm. You can now close this window. Now we can add a K-means widget from the unsupervised panel. Connect it to the Select Columns widget and double-click on it. First of all, let's deselect the normalized column preprocessing, as it may lead to some strange behaviors with our data. Now we can decide the number of clusters, in a fixed way, or selecting a range. If you click on the second option, you will see that the silhouette score panel will appear. This will give an indication of how good a certain number of clusters will represent our data. Once you click on one of the numbers on this panel, you will choose that as output from the widget. As you can see, the scores of 2 and 3 clusters are close to each other. Let's see what the difference is. First, select 2 clusters and close this window. Let's add a silhouette plot widget to the canvas from the Visualize panel. Connect it to the KMeans widget's output and double-click on it. Here, you can see the plotting of the silhouette score for each football player. Set the annotations to the player name. When hover on a line of the chart, you will see the player name. When scrolling, we can see that some players in the first cluster C1 have a score that is negative. Thus, they are probably not assigned to the correct cluster. Let's check what happens when selecting 3 clusters. Go back to the KMeans widget by double-clicking on it. Select the 3 cluster line on the Silhouette Scores panel, and then back to the silhouette plot. The situation is similar, with cluster C1 and C2 containing some players with negative values, and cluster C3 containing the majority of the players. You should pay attention that there are just a few data points with negative silhouette value. We may accept this selection. Let's finally have a partial visualization of the data. Since the clustering is a multidimensional problem, we may choose 2 out of the 54 columns to visualize the data. Let's add a scatter plot widget from the Visualize panel to the canvas, connected to the KMeans widget and to the CSV file import widget. As an example, we can use the following setting for visualization: the number of goals and shots respectively for the X and the Y axis. Set the color to the cluster feature. Size the points using the shots on target. You can also color the regions. Some players don't have shots and goals, so they are excluded from this visualization. Here we can find a possible description for our cluster assignment. We may find that the blue cluster C1 contains the higher scorers. The green cluster C3 contains the lower scorers. And finally, the red cluster C2 contains the players in the middle. You can play with the visualization to find other interpretation of the data. For example, using the crosses and recoveries as X and Y axis features, plus the number of assists as sizing of the data points. This will give you another point of view on the clustering information. That's all for today. In this video, we've learned how to use numerical features to perform unsupervised learning, adjust the number of clusters, and visualize the clustering results. In the next videos, we will focus on how to deal with textual data and use unsupervised learning on it. Ciao!